Alrighty, wonderful children, we've got ourselves the 6-4 to 6-7 quest review. Exciting stuff. One might even say that it is quite radical, if you will, because square roots are radicals. Isn't that hilarious, Jessica? Yes, Jessica says it's funny. All right, let's hop to it. Yes, I have a spectator in here, so they'll very much enjoy all the radical stuff. Oh, that's going on here. All right, first off, let's simplify. So we're going to go way back to operations with radicals, some simplifying and things like that. We'll try to keep it by section and stay organized. All right, so this one here is subtraction. So I'm definitely going to want to distribute that negative to both of those, making it negative 3 root 7 minus root 12, right? And over here I'll have 2 root 3 plus 5 root 63. All right, I distributed my negative, good to go. Hopefully I don't make any minor mistakes. Every one of these videos seems to have one. Hopefully I don't today. From here, let's go ahead and simplify these radicals, shall we? So this will break down. And everybody does this a little bit differently, but you could do like 9 and 7 right now. You could do 3 and 21 if you want to go smallest numbers possible, 3 and 21, 3 and 7, and then I've got a pair of 3s, a 7 stays out. So I have 2 root 3, which cannot be simplified, plus the 3 comes out and multiplies to the 5, which gives me 15, and I have root 7. Then I have minus 3 root 7, and then over here my 12 will be 2 and 6, 2 and 3, grab my pairs, minus 2 root 3. Gucci so far. Now I can combine any like terms. So if they have the same radical, the same number inside the radical, excuse me, I can combine them. 2 root 3 minus 2 root 3, those are gone. And then I have 15 root 7 minus 3 root 7, so 15 minus 3 is 12 root 7. We are done with that problem. Moving on. Simplify. Division. Common mistake, multiplying by the wrong thing, okay? We need to multiply by the conjugate, so root 7 plus root 12. If you'd like to simplify the root 12 first, you can. I'm going to leave it like this for now, but do know that you can simplify root 12. That's going to come into play at the end there. So I have root 7 plus root 12 and root 7 plus root 12. This way, I'm multiplying by a very creative form of 1. And it's going to allow some cancellations in my denominator, right? So my numerator is pretty straightforward. Distribute that 2, and I get 2 root 7 plus 2 root 12. My denominator ends up being, well, root 7 times root 7 is root 49, which is just 7. And then the same happens with the 12 and 12, which is 144. The square root of that is 12, so minus 12. Coolio. I like it. That's awesome. And fantastic. All right. Now I need to combine some like terms here. So my denominator, it's going to become negative 5, right? But I can also simplify this 12. Why don't I do that real quick? I'll do it off to the side like this. We got 6 and 2, and then we got 3 and 2. So I get a pair of 2s. Okay, so my numerator is 2 root 7, and then pair of 2s comes out, so 2 times 2, because of this existing 2, gives me 4 root 3 all over negative 5. Can I divide by the same thing? No. I have 2, I have 4, and then I have negative 5. I can't reduce. If this was like say a negative 6 down here, then I'd be able to divide everything by 2. Okay, let's do a little sidebar. Let's just say, what if, not as exciting as the Marvel series, but almost equally as exciting because it's math, right? What if I had something like 2 root 7 plus, 4 root 3, but my denominator, as I said, was negative 6. What if? All right, for this one, I can divide everything by 3, or I can divide everything, by 2, or I can divide everything by negative 2. If I chose negative 2, it'd be negative root 7, and then it'd be minus 2 root 3, and divide by negative 2 down here gives me positive 3, and I would have this right here. So there we go. If there were simplifications, that could be done. You can. Ours did not have that, but we had the wonderful what if scenario. So that'll work. You could also write that with the negative just out in front. So I could have the negative right here out in front. Or it can actually be distributed through, and you'd have negative 2 root 7 minus 4 root 3 over 5. That's another acceptable answer there. Okay, so the negative could be out front, it could be in the denominator, or it could be distributed through the numerator. If it's multiple choice, you're going to have to be able to identify any one of those 3. Okay, cool. Simplify again. Now I have addition. So there's no distribution going on here because, there's nothing to distribute. So really, I'm looking at this problem. The parentheses are really not doing anything. Let's just start breaking things down. So I get 2 and 20, 2 and 10, 2 and 5. I get a pair of 2s, so it would be 2 root 10. Over here, I'd break down the same way, 2 and 40, so on and so forth. Oh my goodness. It's a lot of writing here. All right, so I got a pair of 2s. 2 times 2 is 4 root 5. Now here with the 10, I can't simplify that, so that's just plus 5 root 10. And then over here, 75 would be 3 and 25, and you get 5 and 5. So you get a pair, and I end up with 5 root 3. So can I put these guys together? Can anything go together? Yes. The 2 root 10 and the 5 root 10 gives me 7 root 10. But then I have the root 5 here and the root 3 here. That will be perfectly acceptable. I either go from like highest radical down to lowest or lowest to highest. There's really not like a standard form, at least not that I know of. Maybe there is one. I just didn't know about it. I'm not that cool. I don't know. All right, but that'll work for us. Cool. Last one of these types with simplifying radicals, and then we'll move on to some other type of content. All right, multiplication here. Almost forgot. 7 times root 8 is 7 root 8. 7 times negative root 6 is negative 7 root 6. Oh man, now we got a couple things going on. So negative 2 root 5 times root 8. That'd be negative 2, and then it's root 40. And then negative 2 root 5 times negative root 6 would be positive 2 root 30. All right, so now I need to break some things down. This I can break down to 2 and 4, 2 and 2. Got a pair, so we get 14 root 2. The 6 I cannot, so minus 7 root 6 stays. Here we already know that can break down, right? That was 2 and 20, 2 and 10, 2 and 5. 2 times 2 gives me 4 root 10, because the 2 and the 5 need to be multiplied back together. And then the 30, I got 2 and 15, 3 and 5, no pairs. So that's going to stay 2 root 30. Do we have any like terms? No, and look at that. It's all in a wonderful little order here. We'll just keep it like that. Woo! That was some good stuff right there. All right, I think I need to have a little bit of a snack, and then we'll come back to some more problems. We got some red peppers. All righty, time for some more simplifying wonderful children. So, oh boy, this one freaks people out, right? So I need to rationalize my denominator. Usually what the most helpful thing to do would be write this in separate radicals as a fraction. Later, Jessica. Bye. All right, so I'd have the cube root of 3b c to the 6th over the cube root of 7a. Okay? Now what I want to do is I want to rationalize my denominator. What is going to allow me to get no radical in my denominator? I need to get perfect cubes in my denominator. So the way I like to think about it is, well, currently I have 7 to the first and I have a to the first, right? So if I were to multiply by 7 squared and a squared, now, and I'm going to jump a step ahead, now my denominator is going to look like this. I'd have 7 cubed, which I think is 243, but who really cares? And then I have a to the third. Well, cube root and cubed are going to cancel, so I'm just going to be left with 7a in my denominator. And since I'm running out of room, I'm going to pop down here. So I'm just going to be left with 7a in my denominator, okay? Now, whatever I do to the numerator, or the denominator, I have to do to my numerator. So I'll do the same thing up here. Cube root of 7 squared, a squared. And what that's going to give me is, well, 7 squared is 49. 49 times 3. 49 times 3. No calculator, right? Well, 50 times 3 is 150. Subtract 3, that's 147. Right? All in my cube root. Okay? And then I have b. Cool. I have a squared. Maybe I should do a squared first. Go alphabetical. A squared b c to the 6th. All right. Now, I need to simplify that, right? I need to look for perfect cubes. Well, 147 is going to break down to 49 and 3. And that's 7 and 7. So I'm not going to have any groups of 3, so that's going to stay. A squared can't do anything. B I can't do anything, but C I can. I can take out 2 groups of C's. So I'm going to have C squared. Then I will have my cube root of 147 A squared B. Boom, done. That is an ugly looking problem. No funzo, right? But hopefully, one, we understand what we're going to multiply by, and also maybe taking a little bit away from this one here where I used a familiar number. 50 times 3 was 150. To get close to it, And then know that I added 3 extra, so I'll take that away and get 147. Hopefully it doesn't freak anybody out doing mental math like that. You all used to be good at mental math at one point in your life, and then you became calculator reliant. All right. Simplify. All right, I'm looking for groups of 4. So 32 is going to be 2, 16, 2, 8, 2, 4, 2, 2. Groups of 4, so whole thing. 2 with the 2 left over. I jot it down up here so I don't forget. How many groups of 4 x's can I take out? Well, that'd be x squared. That's 8 of them, right? It'd leave me with 2 in here. I can take out 1 group of y's, leave me with 3 of them still in there. Then I can take out 2 groups of z's with no leftovers. 4th root, don't forget that. Half point off, man. Woo, don't want that. X squared, y cubed. Boom. Awesome. I'm running out of time. I got 12 minutes, okay? So we gotta hustle here. Okay. Next, oh my goodness. 2 different things? Wait, hold up a sec. Can't I just do this? Square root. Can't fool me, bro. Can't fool me. Raising to the 1/2 is the same as the square root. I'm just gonna change it. Yes. All right. Now, we can either simplify individually or multiply them together first. Personally, I like to multiply them together first if the numbers are manageable, okay? There are tricks to doing it when they aren't, but I've got 16, I got x to the 10th and x to the 1st. That's x to the 11th, y to the 12th and y to the 4th. That is y to the 14th, because I'm adding my exponents, and then z to the 1st, and 1st gives me z to the 2nd. Now I can break this down. Well, the square root of 16, that's 4. It's a perfect square. I don't even need to do a factor tree. It's the square root of 16 is 4. Now my pairs of x's, I can take out 5 pairs of x's, leave me with 1 x behind. I can take out 7 pairs of y's with nothing left behind, and 1 pair of z's with nothing left behind. So I'm just left with that. Woo! I am moving fast. Really hoping I don't make a mistake. Please pop it in, email me or whatever, and I'll address it in the description if needed, as is tradition. All right. Write an exponential form. 2 different examples. I wonder why. Okay. So if I'm going to do exponential form, right, this 3, that's my denominator of my exponent, and the 4 is my numerator of the exponent. So what I'm going to have is 2x raised to the 4/3. All of it. Cool. But this one is a little different. Notice how the cube is only applied to the x and not the other number 3 right here. So what I'm going to have is 3 to the 1/4, but then the x is going to be to the 3/4. This is a sneaky one. I think it was on the quiz, right? It was a sneaky. Okay. Write in simplified radical form. So I need to convert this to radical form. Maybe first I'm going to multiply these. Think of that 7 as like 7 over 1. And if you forgot how to multiply fractions, we multiply across. 7 times 2 is 14, so I get x to the 14th. 1 times 3 is 3, so I get 14 over 3. Okay. Now, radical form, that's the cube root of x to the 14th. But it does say simplify. How many groups of 3 x's can I take out? Well, I got 3, 6, 9, 12. 15 is too many, so 4 groups, x to the 4th. That was 12 with 2 of them left over, so the cube root of x squared. There's my final answer for that one, okay? This right here will only get you partial credit. Full credit, simplified. Evaluate. All right. So for this one here, remember our process is to first root it, then do the exponent. So the cube root of 8 is 2. So I'm left with 2 to the 5th. 2 to the 5th is 32. I'll do them one at a time. The 4th root of 81 is 3 to the 1st is just 3. And then what the heck is going on here? That's like this a negative. How about this? What if I did this? 16, or hold up, 1 over 16 to the 1/2, right? If I have a negative exponent, it's just a reciprocal. All right. So the square root is what I'm doing of that, which would be 1 over 4. Well, since this is no calculator, perhaps what would be helpful is doing 32 times 1/4 first, right? That's going to give me 8. So then I just have 8 times 3, which is 24. Look at that. Pairing up, because multiplication we can rearrange, right? Pairing it up accordingly can help you out, keep numbers a little smaller. Cool. All right. This one here. Let's see. We have, you know what? Pause the brakes. Pump the brakes. This is what we're going to do. All right. Had to change it. Sorry. All right. So we're going to do, we got the square root first, right? So that'd be 3. And then the square root of 16 would be 4. And then this would all be raised to the third power. Do it individually. If you need to write it out like square root to help you, that's cool too. But that's about it. So 3 to the third is 27. 4 to the third is 64. There's my final answer. We got to know those facts, right? Got to know those, 2 all the way through like the 6th power, 3 to the 4th power or so, and so on and so forth. Just like we wrote down in class. I'm sure you guys did, even if you didn't have me. I'm sure you wrote down something like that. All right, for this next one here, guys, we're going to solve for x, and it's a tricky one here. All right, so first up, I got to get rid of my radical right there. All right, so we're going to square both sides. All right, so that will cancel that bad boy out. I'm left with 3x plus 28 equals x squared plus 12x plus 36. If you were thinking that was just x squared plus 36, you were dead wrong. All right, we got to FOIL that. X plus 6 times x plus 6. Boom. All right, so now I've got 0 equals x squared plus 9x plus 8. Okay. Well, I got to factor this, right? That's why I set it equal to 0. So if I'm going to factor this, it's going to be x plus 8 and x plus 1. That multiplies to 8 and adds to 9. So I'm going to get x equals negative 8 and x equals negative 1. Both are potential solutions. We got to double check, right? If I plug negative 8 in, I get negative 2 over here with the original problem. Can a square root ever equal a negative number? No, that's extraneous. If I plug negative 1 in, I get 5. And if I check it over here, I get negative 3 plus 28 is 25. Square root of 25 is 5. This one checks out. We're good to go. Negative 8 is extraneous. Watch out for that. All right. Let's try another one. All right, for this one here, we want to solve for x once again. Again, I'm going to have to square both sides because my radical has already been isolated. So now I'm going to have 2x plus 8 is less than or equal to 4. And then we have 2x is less than negative 4. So x is less than or equal to negative 2. All right, good stuff. Wonderful. So is that it? Well, let's see here. If my numbers keep getting smaller, 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 eventually negative, like a negative 10 is less than or equal to negative 2. That's going to cause a negative inside my radical, and that's no bueno. So I do have to do a domain check here, domain restriction. So I'm going to take my inside of my radical, right? And I'm going to set that to be greater than or equal to 0. So I get 2x is greater than or equal to negative 8, and x is greater than or equal to negative 4. You need both parts here, written as a compound inequality where x is between negative 4 and negative 2. Bingo, bango. All right, I think we have time for one more. Uno más. Uno más. All right, this next one here, we're going to solve for x. All right. Now, when I square both sides of this one, I can't isolate the radical, and I've got some coefficients to worry about. So when I square both sides, I'm going to have 16 and then parentheses x plus 3, and then I'm going to have 9 parentheses 2x, right? It's going to cancel that radical, but it also squares that coefficient. So now I have 16x plus 48, and I have 9 times 2 is 18x. So I'm going to subtract 16. I'm left with 48 equals 2x. So I'm getting a little sloppy there. 2x, and then divide by 2. I get x equals 24. I do need to still check this in the original problem. I'm going to get positives in my radicals. Everything looks to be wonderful and fantastic. One thing I did want to check or do real quick here is, what if I had a negative? Let's keep it real simple here. Negative square root of x plus 2 is less than or equal to, how about just less than 10? Okay. Well, actually, let's go with negative 8. So what am I going to do here? First, I got to divide by this negative 1 coefficient, right? That's like a negative 1 right there. So when I do that, what happens to my inequality? I have x plus 2 is greater than 8. And now I go about solving this. So when I square both sides, I get x plus 2 is greater than 64. So x is greater than 62. If I plug this back into the original, right? I have, when the original was this, square root of x plus 2, negative square root of x plus 2 is less than negative 8. Well, that would give me, right here, if I plug it in, I get 64, square root of 64. Boom, right? I'm going to get numbers that are smaller. It's going to check out because this gives me exactly what it is, but everything is less than 62. So we're okay here, no extraneous solution. Bingo, bango. Main thing there was we got to remember to flip our inequality. All right, that was the bell. Got to be done. You guys ready for some math? Yes, they are. They're ready for math. All right, American Freedom, Rock and Roll, Costco, Riverdog Jenny on the gram. See ya.